Hello and welcome to our Group 10's video demonstration of the group project, the Map2D ADT. In our group, we have 4 members, Lê Việt Bảo, Nguyễn Vinh Gia Bảo, Tô Nhật Duy, and Nguyễn Hữu Quốc Huy. In this video, we will be talking about the problem, the class diagram, the data structures and algorithms used, the time complexity analysis, and lastly, the demo of our system. So first, the problem. This problem requires us to create an application which is similar to Google Maps, but without any front-end or user interface. It has to be able to find the nearest services from a location and return them if they are within the specified rounding rectangle. These are the technical requirements of the project. For the map size, the maximum size of 10 million by 10 million. The search area is a bounding rectangle with side length from 100 to 100,000. Service types, each location can have at most 10 services, and the location Map2D has to accommodate maximum 100 million places, and the search result has to display at most 50 that meets the search requirements, and the Map2D class has to support add, edit, remove, and search functions. Now we'll talk about the class diagram. So firstly, class Map2D has several dependence relationships with quad tree, place, rectangle, and array list as it uses various functionalities from these classes. Next, quad tree depends on service registry to access services. It has a composition relationship with rectangle as it contains a rectangle object. It also has an aggregation relationship with place as it manages many place objects. It has an association relationship with array list as it uses array list to manage all the place objects. And lastly, array list implements the iterable interface and uses iterator to implement part of the iterable interface. So the place class is used to represent each location on the map, and these are the methods and its description. The rectangle class helps with the search function as well as it is an integral part of the quad tree class. These are its methods and description. The ArrayList class is made to replace the functionality of the ArrayList class in the Java Collections framework. These are the methods and description. And with the quad tree class, and this is used to store and query the spatial data quickly and efficiently, and is important to Map2D. These are its methods and description. And lastly, we have the helper classes, which are created to be helpers and helpers functions. With the service registry class, iterable type T interface, and iterator type T. And lastly, Map2D, which supports add, edit, remove, and search functions. Now we'll talk about the data structures and algorithms used. So for the quad tree, it is a hierarchical data structure, which is commonly used to partition a two-dimensional space recursively into 4 quadrants. Each node in the quad tree represents a region of the space. These are the key methods of quad tree, which are get current capacity, subdivide, insert, query, and generate service bit mask. And the array list data structure, which is a dynamic auto-sizing array implementation, is able to adjust capacity as elements are being manipulated, and is well adjusted for fast random access. The key methods of this data structure is add, get, size, clear, and remove, which are described previously. And now we'll talk about the time complexity analysis of some key algorithms. First method, subdivide, which has a complexity O n because the redistribution involves iterating through all points n and attempts to reinsert them into the new quadrants. The second method, insert, which has a average time complexity of O log of n and has a worst case complexity of On. The average case occurs when the tree is balanced, while the worst case happens when there are a lot of points in close proximity. And with the query method, which has the best case of O log n and worst case of On. The best case occurs when the query range directly corresponds to a quadrant or a set of quadrants, but much overlap, while the worst case happens when the range intersects multiple densely populated quadrants. And now we will show you the demo of our system.
So the next thing that our team want to demonstrate is our Map2D abstract data type. Now I will run the main function of the class. When I run the main function, it will randomly add 100 million places onto the map. And these places will have random x and y coordinates alongside with random services that are assigned to them. Since we're adding so many places, it probably will take some time. There we go. Now you can see our menu, which has the 4 basics operation and a 5th one, which is exiting the program. The first operation that we want to show you is the search operation. It will ask for an x and a y coordinates, which I will, for the purpose of this demonstration, I will choose a random number like 4 and 5, and the width and the height, I will let them both be 100,000. And first, let's search with a service filter. I want to find places that are restaurants. As you can see, it has found 1,850 results, which all has restaurant in them. Of course, we're only displaying up to 50 places. I will do that again, but this time without the search filter. We will search the exact same area. And now, as you can see, it has found 10,000 places. The next function that we want to demonstrate will be add a place to the map. I will add it as the x coordinate of 4 and y coordinates of 5. It will ask for a service type to go along with the place. I will make it to be a cafe, and I will add more service type to the place, which is a restaurant. As you can see, this is our place that will be added to the map. Now that I have checked it, I think that will be enough. So I don't want to add any more service type. Now I will edit the place that we have just created, which is 4 and 5, which has the x coordinates of 4 and the y coordinates of 5. And I will add another service to it. Let's say I will add I will make it also be a store. And as you can see, the service store has been added to the place. Of course, you can also remove the service. You can also remove services from the place. Let's say I don't want it to be a restaurant anymore. So As you can see, the service restaurant has been removed from the place. And to show that the place has actually been added to the map, I will perform a search function again on the same area that I have searched with no filters. And if you've been paying attention, you will see that the last time I searched this same area with no filters, I have found 10,092 places. But now that I have added another places, it has become 10,093 places, which proves that I have added it to the map. And now we will remove the place that we have just added. Of course, you can also choose like a random place from the list that we display here. But for our demonstration, I will remove the place that we have just added, which has the coordinates of 4, x coordinate of 4 and y coordinates of 5. And place, it says place has been successfully removed. Let's check that. We will search the same area again without service filters. And as you can see, it has become 10,092 places again. So that will be the end of our demonstration. Thank you for listening, and I will be exiting the code now.